Welcome to this talk where we're going to be talking about boosting developer productivity with Buildpacks, and specifically talking about how standardizing your builds with Buildpacks can give you benefits at build time and runtime. So my name is Joey Brown. I'm sharing the stage here with Joe Kutner. I'm going to introduce myself and I'll give him an opportunity to do the same. So I'm a platform engineer at Heroku. Heroku is a platform as a service, and we build hundreds of thousands of apps a day. And the way we're able to do that is because we leverage standardization through Buildpacks.
And I'm Joe Kutner, and I thought Atlanta was going to be warmer than this. I'm a DX architect at Salesforce, which is a parent company of Heroku, so I like to tell Joey that I'm his father figure. But I actually used to work at Heroku. I was there for about 8 years as developer experience architect, and that's where I co-founded the Cloud Native Buildpacks project.
All right. So let me give you a quick introduction to Cloud Native Buildpacks. So Cloud Native Buildpacks are a tool that inspects your source code and figures out how to package that up into an image and run your application. And okay, you might think, okay, we've got a way to build our applications into an image. But let me tell you a little bit about why Buildpacks is different than the build system you might be using. So first of all, Buildpacks builds your apps as a service, right? Basically, you just take your source code, you hand it over to the Buildpacks, and the Buildpacks takes it and builds an image. So it's kind of like when you got a bunch of stuff you want to send somewhere in a parcel or something. You can take all your little doodads, whatever, take them in your hand, take them to FedEx office or whatever, hand them over. And the folks there know how to package it appropriately, put it in the box, ship it, and send it. You don't have to follow some checklist or get permission from the delivery driver to make sure that your image is okay, right? So this is nice because your developers don't have to become experts in building line-by-line instructions to build their images. And not only does Buildpacks pack up your image for you, it does it in a modular and intentional way. With Buildpacks, your components are logically mapped to the layers in the image. And it's kind of like, getting an iPhone and unwrapping your nice iPhone. Every little piece in there has its own spot, place for everything. You've got your charger, your headphones. You used to have headphones, and it was all neatly organized inside this little box. As opposed to, when you buy something on Amazon and, they just kind of throw everything in there. It's the wrong size box, kind of rattles around a little bit. It's not very intentional. So Buildpacks brings this standardization and this mapping, this logical mapping from components to layers is really a key to unlocking developer productivity. And I'm going to get into that in a moment.
Yeah, so what you're seeing here are a number of vendors, companies that have adopted Buildpacks, or they have implemented it within their developer platforms. Some of these are internal developer platforms, like at Salesforce, the one that I work on, and others are external facing for customers, like Google Cloud or Heroku. In order to have a platform that supports Buildpacks, you got to do the work. And so you come to Buildpacks from a couple different personas. There's the platform engineer who needs to do the work of implementing the Buildpack framework and execution engine within a platform. And then the application developers who, dang it, they just want to build an app. They want to use Buildpacks. But there's a sort of chicken and egg problem here, because in order to use Buildpacks on your platform, some platform engineer has to have gone and done the work to make that possible. How many of you consider yourself a platform engineer? Whoa, man, that's like 100%, right? So, any application developers? A couple, all right. People are still building apps. That's good to know. You can't just have platforms. But yeah, so we have a chicken and egg problem here. And if your platform doesn't support build packs, you got to build containers some way. And obviously the most common way developers are building container images is by writing a Docker file. It's quick and dirty. It lets you build a container image the way you want. It gives you a lot of autonomy and flexibility. But with that, there's some trade-offs. With that autonomy comes ownership of certain components that you may not have otherwise had ownership of, like the base operating system and all the packages, the third-party packages that go into it. There may even be some like networking or certificate configuration in there that you'd rather have the platform own. But now you're on the hook to keep these things updated as an application developer. Dockerfile also doesn't give you any kind of like modularity or way to reuse code or composability between different Docker files. All you get is just sort of a linear from this next image, from this next image. So there's some trade-offs here, right? So that's why a lot of application developers just want to use build packs. It allows them to divest themselves of owning all those other components. It lets them focus on what they do best, which is writing application code and having it run in production. Fortunately for them and for the platform engineers, there's a number of options in terms of adopting build packs within your platform. There's Kpack, which is a K8s operator for running build pack builds in a cluster. There's the pack CLI, which is a binary that you can run locally. You can also drop it into Jenkins. And then we also have GitHub Actions and other CI integrations that are built around this platform, so you can run it in those platforms. There's a Tecton integration, and then there's Spring Boot, which can just run in your traditional CI environment. In any case, some platform engineer, dang it, has got to do the work of getting this into the platform before an application developer can use it. But that's not the end of the story. Once you have the ability to run build packs, you need some build packs that you can run. Now, fortunately, there are some off-the-shelf build packs from Heroku and Paketo. There's also ones from Google, but they're very sort of specific to the Google Cloud platform. So in most cases, you can take these build packs, run them against your app, integrate them into your workflows, and everything's fine. But you are sort of giving up some autonomy when you do this, right? You're dependent on what the Heroku build pack supports and implements in order to build your app. Now, they're very full-featured, but every once in a while you want to customize in the same way that you do with Dockerfile. I should say it's possible to use Dockerfile in conjunction with build packs, but that's sort of a special case, and we're not going to go there. Instead, we're going to talk about how application developers can use build packs, but still have autonomy that feels very similar to what you have with Dockerfile. This is called inline build packs, and very similar to how you drop a Docker file in your repository. I'm going to do a little demo of dropping a project toml, which is a generic project descriptor file that can have configuration and metadata about any kind of project. And one of the things that it can have is inline build packs inside of it. So let's go ahead and take a look at that. So the resolution will come in a second here. This is just a very simple Python Flask app. I think I generated it with Claude Code or something, and it has a few HTTP endpoints. It has a PyProject toml that just declares some dependencies. Nothing special. That's not the important part of this app. We just want to use this as an example of something we can build into a container image. So the first thing I'm going to do is touch my project toml and then open it up in VS Code. So just at the root level of my directory. And then I'm going to paste in some sort of boilerplate here. I've defined the schema version of the project toml. That's just the schema version of the whole file. And then I'm setting up a build packs namespace. So all the different configurations that go into this project toml get namespaced under sort of who owns them. So the io.buildpacks is all the build packs configuration. The first thing I'm defining is my builder image. This is sort of equivalent to the from statement in a Docker file. This is the base image that's the inline build pack is going to run inside of, that container that it's going to run inside of. But the builder image is actually much more than just a base image. It contains that build execution environment. It also contains a set of build packs that I can use as part of the build, or not use, as I'm going to show. And then it contains a reference to a run image. So it's both a build image and a run image, where I can do things in the build and then put those layers on top of a run image. This is kind of analogous to multi-stage builds in Dockerfile, but in multi-stage builds, it's just like copy this stuff, and you can't do things with like nvars or like whole layers. So with build packs, you get a little bit more control over building a layer here and then putting these layers on the run image. But for my purposes of doing an inline build pack, just like the from statement. The next thing I'm going to do is set up a build pack group. If you're not familiar with TOML syntax, this double bracket just means I'm creating a list of things. I'm creating a list of build packs, of which I'm only going to have one right now, and that's my inline build pack. So I've set up the ID of it, the API version, just kind of standard metadata. This inline script is really the important part. Now, I can write my build pack as a single script. I don't need a DSL like in Dockerfile. I can just give it a full script. I can use Bash. I can use Python. I can call out here to a binary that was built with Golang, whatever you want, right? There's a lot of flexibility. But for my purpose, I'm going to run UV, which is the latest and greatest Python package manager. We promise it's the last one. This one's really good, but I want to use it in my image, and maybe it's not supported in my build pack, right? So I'm going to set that up in this script. So first thing I do is run a curl command, and then it's going to put that in my home directory. I'm just going to copy that, the UV binary, into my workspace. That way I get it in my production image. That home directory by default is excluded. And then finally I'm going to have my script run UV sync, which is going to install my dependencies, actually installs Python, and set up my app for production. So that's it, just those few lines. That's my build pack, right? Just a few lines of code. Now, if I had a Docker file and I wanted to build the image, I'd run docker build. But this is not a Docker file. This is a project TOML. So I'm going to use the pack CLI and run pack build. And then I'll call my image KubeCon 2025. So this pack build command is basically just analogous to docker build. It's going to do many of the same things. It's going to pull down the latest version of my builder image, and then it's going to essentially start a container that runs a build inside of it. And here it is. It's running my inline build pack script. So the first thing it's doing is downloading UV, shuffling that around, and then downloading Python and installing all of my dependencies. And at the very end here, it creates a bunch of layers. And you can see I actually did this once before. So it's reusing layers if I already had them. But it's taking those layers and putting it on top of my run image. Now, at the end of the day, though, I get a container image, honest-to-goodness OCI Docker image. Even though I didn't use Docker build, it's still compatible with Docker. So I can actually run the image I just created with a Docker run command, or I can send it off to a cluster and run it there. I'm going to do that locally, just expose port 8080 and then run the image. And the command I'll run will be uv run app.py. So here it sets up Python and then starts up my app. Cool, and now it's available on localhost. Nothing special here. The app itself is not the point, like I said. I just wanted to show that it's a standard container image. But because it was built with build packs, I can also use pack inspect command to get a little bit more information about this image, because there's a bunch of metadata in the config blob of the image. So I can see the various build packs that were used, the base images that was used. Actually, there's a separation between the base image and then my application layers. We keep a reference to that so we can do things like rebase, which Joey's going to talk about in a minute. But basically at the end of the day, by creating this inline build pack over creating a Docker file, I'm getting that autonomy, that flexibility, but now I've unlocked a lot of the power of build packs. I can do things like rebase, Joey's going to talk about that. I can also start composing in other build packs. So that Heroku builder image actually has Java build pack, Node.js build pack, some other things, PHP build pack. And I could just reference those in my project TOML, and they'll compose in with my inline build pack. I can run them before it, I can run them after. This is one of these capabilities of reuse and modularization that the build packs framework provides. I won't execute that right now. There's a lot of possibilities there, a lot of build packs on the build pack registry you can pull from as well. Last thing, as I mentioned, because this is a build pack built image, I can run pack rebase. This is going to update my image, the base image of my image. So as soon as there's a new Ubuntu or whatever, I can run pack rebase. And without actually running a full build, I'm literally just swapping in some layers here. I get a new image that's up to date. A lot of complicated things that happens there, but I think Joey's going to tell us about that.
Awesome. Thanks, Joe. All right. So, like Joe demonstrated, you're able to get up and running with Buildpacks pretty quickly, pretty simply, right? Now, we haven't unlocked the full potential of Buildpacks yet. And in order to get there, I want to take a moment to just go into a little bit about how those application images are created. Okay, so like Joe mentioned, we start with this builder image, right? This builder image has everything you need to build your application. It's got, various build packs. You've got, the various language support that your platform might support, like Python, .NET, whatever. So your your builder image has multiple build packs, and it's also got a reference to that run image, right? So when we actually build the app, we take the layers from the run image and we apply the layers, your application layers that are built through Buildpacks to create a new app image. And again, this is a standard approach, and this means that all your applications, disparate apps are using the same base image, the same approach, the same standard approach. So how does this help with developer productivity? Well, for instance, it allows for a very, very powerful caching mechanism. So we like cache. Cache has never caused any problems, right? But no, we like cache. We want to build our images quickly and efficiently. So if we think about a build environment you might be familiar with, like Dockerfiles. Dockerfiles offer a very simple, naive cache. Dumb. It's your artifacts are not logically tied to those layers. It's the actual line of instruction that's tied to those layers. It's arbitrary, it's naive, it's dumb. It can be better, right? So what this kind of forces you to do, it forces developers that own this Dockerfile to engineer and design efficient builds to take advantage of what little caching mechanisms we have, right? Developers kind of have to hack around things to get an efficient build. I was involved in a project some years ago where our app image was built with both .NET and Node.js. And what we had to do when we were developing this is, depending on what we were working on, we might actually change our build, change the order of instructions in the Docker file to take advantage of this. So, if we were working on our Node project, we didn't just blow away the cache of the .NET build just because it came after it. So this intentional layering, where you're mapping those components to the layers, it boosts developer productivity because the developers aren't responsible for engineering this. Developers don't have to spend time and effort designing their line-by-line instructions to take advantage of the cache. They get this for free with Buildpacks. So let's take that logical mapping, one step further. So we talked about the advantages that it provides at build time, but this logical mapping of components to layers also really helps us at runtime, right? So once your image is built and you've got containers out there running in production, things can happen. Security vulnerabilities can be found. You got your CVEs that might be identified on your base image. And so how do you deal with that in a Docker file world, right? Well, that base image is like the first line in your Docker file. Maybe it's not. Maybe you're using a multi-stage Docker file and you might be able to benefit a little bit from caching. But by and large, you're going to have to rebuild all your applications because it's, that base image, it's the very first line. It blows away everything after that. So you have to build again. It's an inefficient build. It's one of the most expensive things you can do. So, and if the Docker file belongs to the developers, this can be disruptive. It's unplanned work perhaps that they need to go take care of. But Buildpacks makes this simple because of the, again, logically mapped components to the layers. So the base image layers are actually denoted inside metadata inside your image. And this enables us to perform something called rebase. So rebase is a process by which when there's a new base image, with its new layers, whatever, we're actually able to take, Buildpacks is able to take the application layers and take the new base image layers and compose them into a brand new image without rebuilding the applications. This is basically a registry operation, right? So you don't have to spend the time and effort of going through the process to rebuild. This is great because this is one less thing that developers need to be involved with, right? This is a runtime operation. It's system security. Your developers that are building apps shouldn't have to worry about this. So Buildpacks provides a convenient mechanism for handling that. Now, with these intentional image layers, there are some trade-offs that come with that. There are some constraints. Buildpacks are not a blank canvas to just, go wild with. You have to work within the bounds. Your options for building are limited to, reasonable things that you might need to do when you're building an application. You don't have ultimate freedom. But Buildpacks is phenomenal at building application images because that's what it's optimized for. So where Dockerfiles offer complete freedom of expression, it requires developers to have to understand, the right way of building it. You've got all these tools at your disposal, but you can only really do things this way on our infrastructure, on our platform. So Buildpacks are limiting in some ways. You can't use root. You can't just go install all the, third-party system dependencies that you want. You're constrained, but it's liberating because your developers don't have to figure that out. They can focus on solving business problems. They don't have to focus on how to solve these problems that come up in the build. And Buildpacks, from the developer's perspective, are simple. So check out this slide here. So this is a Dockerfile template that's provided by Ruby on Rails when you generate a new application. This is like, I don't know, it's a lot of lines. 200 maybe, it's a lot. But this was expertly crafted by the Rails developers, and I'm sure it's great. It'll get you a production image that you can take and run with. But it's great for day one, you've got this golden Dockerfile image that you can use to build and run your app. But what about on day two? When you're developing this application and it's becoming a little more complex. You're given that golden Dockerfile, right? But now you have to go in there and make some changes. You have to adapt it to your application as it's being developed. And you have to maintain that Dockerfile. So what happens when, there's another team that has a Rails application? Well, are they supposed to use that Dockerfile provided by Rails, or are they supposed to copy and paste yours, or are they supposed to do something else? The Dockerfile approach, it's not a standard. This thing provided by Rails is an example. It's not a standard. So standardization allows separation of concerns and specialization. So if you go back, and you think about the days of yore when you're FTPing binaries onto servers, that was nice. It was developers maintained the apps, and your infrastructure team, your platform team maintained the integrity of the system. They maintained the security of the system. And now in the cloud native world, the artifact of the application build is the system. It's an image. It's got like a whole operating system on there. The artifact is the system. And that's great because you've got a standard image that can run anywhere where you can run containers. It's flexible. It's great. We're all here at the Cloud Native conference, right? But in doing so, in requiring that build artifact to be the system itself, oftentimes that responsibility for building that whole system image falls onto developers. And we lose that specialization. So we're kind of throwing the baby out with the bathwater. We say, here, developers, you just ship a whole system, right? And so we make developers responsible for the system. And we're really pushing full stack developers to become even fuller stack developers. Developers have enough responsibilities as it is. We want our developers to be focused on solving real business problems. We don't want them to become responsible for these systems, right? So Buildpacks really help restore kind of this natural order, this natural dichotomy. It allows specialization and enables separation of concerns. So through this specialization, your developers can be more productive because they can be focused, again, on solving those business problems. They don't need to be focused on solving system problems.
Yeah, I think this point about standardization is really important when it comes to productivity, and both for platform engineers and for application developers, because standardization is how we ultimately boost productivity by way of standardizing the interface into the platform. Like I think one of the problems that we run into too often as platform engineers is having a mess of an interface, lots of APIs, lots of different information architectures that don't necessarily pair up well. And Dockerfiles is another example of where every app developer ends up creating a snowflake that the platform then has to be able to support. So standardization from the platform side allows you to do image scanning better, maybe have default operations that will execute because the base images are going to be this way, or the application components are going to be set up in the image a certain way. And then for the application developers, it's standardization such that they don't have to care about the platform. So this emphasis on standardization, I think, is a really important aspect of both platform engineering and anyone who's building container images. Cool, so we have a project kiosk down in the project pavilion if you want to learn more about Buildpacks. I think we're just at time, so I'm not sure if we'll have time for questions, but we'll definitely be down there. Did I put the times in here or no? I guess I didn't. It's the afternoon slots, so I think it's from 2 o'clock to 5 o'clock tonight, and then also the booth crawl till like 7:45.
Yep,
and then it's Wednesday afternoon and Thursday afternoon. So yeah, come swing by there. There's also the Heroku booth if you want to learn more about Heroku and how Heroku's using Buildpacks. But yeah, we'll be there all week and happy to answer questions. So thank you.
Yeah, thank you.